Hi everyone! Today we'll explore Object-Oriented Programming or OOP. OOP is a way of designing programs around objects, things that have data and behaviors, rather than just a series of instructions. This makes code more organized, reusable, and easier to scale for large projects. Think of it like planning a city. Instead of one long street of random houses, you design neighborhoods with clear structures and roles.
Object-oriented programming versus procedural programming. Before OOP, programmers mostly used procedural programming, which is like writing a recipe, step-by-step instructions grouped into functions. Here is an example of procedural programming. Here, we just execute steps directly. In OOP, we bundle data and methods inside classes and create objects. Here is an example of object-oriented programming. The calculator object keeps its data and operations together. Here are the advantages of OOP. It is easier to maintain and update large projects. It also encourages code reuse through classes and inheritance. And it makes complex systems more organized and scalable.
The key concepts of object-oriented programming. Class and object. A class is like a blueprint and an object is the actual product built from it. Imagine a blueprint for a smartphone. The blueprint defines specs like screen size and battery life. Each physical phone you buy is an object with those specs. For the sample code, smartphone is the class and phone is the real object.
Encapsulation. Encapsulation is about protecting data by keeping it private and providing controlled access, like a locker with a key. Only authorized methods can open it. Getter method to access and setter method to update the value. For the sample code, here the balance can't be directly changed from outside, preventing accidental misuse.
Inheritance. Inheritance lets one class reuse and extend another's features, like a restaurant menu. All menu items share some common traits, such as name and price, but a dessert might also have an extra property like sugar level. Here is an example of inheritance. Dessert inherits the basic properties and the display behavior of menu item and can add more details such as sweetness level.
Polymorphism. Polymorphism means a single method name can work in many forms, like an universal charger that fits different gadgets. For the sample code, the method print behaves differently depending on the actual object.
Abstraction. Abstraction is showing only what's necessary and hiding complex details like using a vending machine. You just press a button without knowing the internal mechanics. For the sample code, users interact with a simple dispense method action without needing to know what the machine works inside.
To wrap up, OOP organizes code around objects, making large programs easier to manage. Compared to procedural programming, it bundles data and behavior, and supports classes, encapsulation, inheritance, polymorphism, and abstraction, which are the building blocks of modern software design.
Whether you're creating apps, games, or large-scale systems, understanding these concepts will help you write cleaner and more maintainable code.
That's our introduction to object-oriented programming. Thanks for watching!